Hey guys, how are you doing? Today in this video we are going to talk about neutrino physics. Neutrinos are commonest burst weirdest particles. They are so mysterious that they are invisible and thought to be massless for decades. They fly through Earth like ghosts. UPSC has asked many questions about neutrinos including IceCube experiment, and UPSC could ask again question about neutrinos. In this video, we are going to decode neutrino physics in a way that is simple but exam ready and deeply conceptual. Before we begin the properties of neutrinos, let me remind you guys, you have seen this in the newspaper, the Hindu newspaper recently. Again, the news was about, the neutrinos mass, and this news was about German experiment sets new limits on the maximum neutrino mass. Okay, again it was in news. So let's begin our discussion about neutrino, right? Neutrinos are second most abundant after photon. And why I am talking about all these things, let me tell you. Okay, so neutrino, right? Neutrinos. And if you have done basic science course, science, in science we have some sort of symbols for neutrino. We use this kind of symbol. It is like it is read as nu also, but this is the symbol for neutrino, right? So neutrinos are second most abundant. They are second most abundant abundant subatomic particles, elementary particles. Okay, subatomic mean smaller than atoms. Subatomic particles after photon. What is photon? Anyone of you know about photons? Photons are light particle, and it is a very important critical difference. Photons are basically particle of lights. They are particles of light, and let me tell you, they don't have mass. Their rest mass is zero. It means they are not at rest. Their rest mass is zero. So there is one interesting physics which Einstein was working, on the theory of relativity, and it says the following: if a particle has mass, if it has mass, it cannot travel with the speed of light. So photons mass is rest mass is zero, right? So therefore it can travel with the speed of light. Remember this thing. This is very important, very important distinction. Earlier, these neutrinos were thought to be massless. They were thought to be massless. And if they are massless, then what? Can you tell me? If they were thought to be massless, it simply means they can travel with the speed of light. And the speed of light is what? It is 3 lakhs kilometer per second, or otherwise 3 into 10 raised to power 8 meter per second in scientific terminology, right? But they don't. Okay, but they don't move through the speed with light, right? So they are light particles. They have mass. They are light particles. Neutrinos are light particles. They have negligible mass. They are not massless. So they are not massless, right? They are not massless. Remember, they are, and other things about their properties. They are not massless. They are electrically neutral. They are electrically neutral. Electrically neutral simple means, electrically neutral means they are not affected by electromagnetic force. Electromagnetic force, not affected by electromagnetic force. Not affected by electromagnetic force. Again, if you don't know the basic science things, you can ask me, freely through comment sections also, right? Let me tell you, there are 4 types of fundamental interaction you should know. There are 4 types of fundamental interactions. Nature has 4 types of forces, right? Mental interactions. Okay, one interaction all of you know. First interaction is called gravitational interaction. It is very weak force, weakest of all, right? Gravitational force. But for heavy bodies, it is significant enough. Then there is another force which is electromagnetic force. If a particle has charge, then they can be affected by these particles, can be, or objects can be affected by electromagnetic force. Both of these forces, they go from atomic level to large distance, and therefore it is called long range force. Let me just a minute. These two forces are called long range forces. Long range forces, because their range, it starts from atomic level to a large level, right? Large, many kilometers. or even for light years also, right? Third one is, for example, gravitational force acts, even at large distance. Third one, these two forces, third and fourth one, they are called strong nuclear force, right? One is strong nuclear force. One is strong nuclear force. Strong nuclear force, it only acts within the nucleus of an atom, and therefore it should be what? It should be short range force. And another force is called weak interaction. It is called weak force, weak nuclear force. And weak nuclear force is responsible for beta decay, and these neutrinos, they are emitted in beta decay. Beta decay, I am going to talk about beta decay quickly. So these neutrinos are, they are basically, they decay in they are produced in beta decay, which is mediated by weak interaction, right? It is called weak interaction. One example of weak interaction is radioactivity, right? You know about radioactivity. Madame Curie got Nobel Prize for Physics in 1903, and in 1911 she got Nobel Prize for Chemistry. She took this radioactivity to a very experimental science, to a very profound science. She worked for it actually, right? Henry Becquerel, he discovered radioactivity in 1897. So you should remember some basic dates also, right? If you could, right? Okay, so these particles, they are only affected by weak interaction, not affected by these forces. So if I am talking about neutrinos, so neutrinos are not affected by, not, they are not affected by these forces, these three forces, right? So they are, you know what, it simply means you can make some inferences out of this statement. For example, they rarely interact with matter, right? They rarely interact with matter. They rarely interact with matter. It simply means they will go undetected. They pass through, they pass through matter, they pass through matter undetected. You cannot detect them. There is no way you can detect them, right? Undetected. So this is why sometimes they are called ghost particles. They are called ghost particles. Like there is God particle, Higgs boson is called God particle. Neutrinos are called ghost particle, right? They can ask you these basic, questions. Ghost particles, and most importantly, what I want to tell you about these particles, as bullet can pass through a blanket of fog, similarly these neutrinos can pass through your body, my body. They can pass through earth, like a bullet is passing through a thick blanket of fog. It means you cannot detect them, right? You simply cannot detect them. Okay, let me write other properties of neutrino. So okay, so neutrinos, let me write, these are the experimental pictures about neutrinos. Let me tell you about neutrinos. Neutrinos can go through everywhere, I told you, right? They are elementary particles. In particle physics, they are called elementary particles. You must know there are, for example, ordinary matter has, if I want to talk about ordinary matter has this, quickly. So if this is atom, right? For example, this is atomic picture. So this is nucleus. Nucleus has proton, neutron, proton, neutron, and their electrons are, they are, they are like, orbiting around nucleus, like satellites are settling around, Earth or any planet, right? Okay, elementary particle is made up of electron. Electrons are elementary particle in a sense, they are not made up of any other particles. Electrons are elementary particles. And these protons and neutrons are made up of further, sub atomic particles, more elementary particles. They are called quarks. So ordinary matter is made up of quarks and electrons. But neutrino is not made up of anything like electrons. So neutrino is not made up of anything. Not made up of anything. It cannot travel at the speed of light because it has mass, right? Right? It has very little mass. It has very little mass. Okay, even at nuclear level. So cannot travel through at the speed of light. Speed of light. This is one, you can say, limitation on the neutrinos, right? Other properties, they are created in nuclear process, right? Let me tell you, and they are created in nuclear process. Nuclear process. Let me tell you, in elementary physics, you must have done, radioactive decays. There are three kind of radioactive decay. Quickly, let me tell you basic distinction. So suppose I have this, material which is radioactive. So I have this radioactive material, and what it is going to do, what I'm going to tell you, so it emits some kind of, invisible rays. Okay, so you should know, all of you must know these basic distinction. Let me give some color for this plate, and for this plate, say this plate is positive, right? This plate is positive, and like charges repel, unlike charges attracts. There are, this material is radioactive material. Let me tell you, this radioactive material. Which material is radioactive material? This material is radioactive material, right? Like radium, for example, for that matter, for which Madame Curie got Nobel Prize in 1911, right? So, some rays, there will be some rays, they will go like that. They will go like that, towards positive plate. Some rays will go undetected, they go undeviated, they will go straight, they are not deflected towards negative or positive plates, right? Some rays are there, which she discovered, and Henry Becquerel is also, working on these kind of rays. They go towards negative plates, and with common sense you can make, common, inferences. These particle has to be negative, these rays should be negative rays, all right? Negative rays. These rays should be positive rays, that's why these rays are attracting towards, or they are going towards negative plates. Okay, these rays are called, these negative rays are called basically beta rays. They are called beta rays. Beta is written like this, beta rays. And these rays are called alpha rays, and those rays which were, undeviated, they are called gamma rays. So gamma rays has to be, gamma radiation has to be neutral, it is not deflected towards either negative or positive plate. I hope you got this. And if someone asks you what is alpha particle, essentially by definition, an alpha particle is, it is the nucleus of, helium. It is helium nucleus. So helium nucleus has two proton and two neutron, right? It should have two electron also, but if we are talking of nucleus, then it should not have, electrons are stripped off, right? Beta rays are essentially fast moving electron. They are what? They are fast moving electrons. They are fast moving electrons. Okay. So this is how an atom which is unstable, it, radiates, and this process, this radioactivity, it is mediated. This radioactivity is mediated by weak force, mediated by, W bosons, but we are not getting into that much particle physics, but mediated by simply, we say weak interaction or weak nuclear force, right? And by product of beta, decay, we have neutrinos. Okay, so let me tell you what neutrino is basically, how you get neutrinos. For example, this is, some nucleus which is unstable. So beta decays as, let me tell you, common way for an unstable nucleus to emit beta decay. So let me tell you, common ways for an unstable nucleus, the nucleus which is unstable nucleus to decay, right? There can be few ways, and let me tell you what are these few ways. First way, with common sense you can understand, if it has too many protons. For example, if a nucleus has too many protons. How many protons? Too many protons. This is one way. Another, if a nucleus of an atom, remember, we are talking of atom has too many neutrons. They cannot accommodate too many neutrons, too many protons. It is unstable, and typically after atomic number 92 uranium, atoms are, elements are unstable, right? So what is going to happen? What physics is going to happen? This proton, free proton, or the generic equation, suppose this element is X, and this is called atomic number. If I have forgotten, guys, so you can ask me, this is mass number, this is atomic number. What it is going to do? It is going to lose one proton, so atomic number will be dropped by one, right? And mass number is going to be same. Okay, this otherwise, if you don't want to learn this generic equation, I can tell you in a simple way, because we want to make this lecture simple for accessible to all students who are from humanity background. So you guys know this P mean proton, N mean neutron, right? E minus mean electron, electron has negative charge, and this is called electron neutrino. So this much you all know, right? So proton goes to neutron. Proton is positively charged, neutron is electrically neutral. So there should be some positive charge, a particle, so that charge is balanced. This is antiparticle of proton, and this is called a positron. What is positron? By definition, it is antiparticle. Antiparticle is same. Almost all properties are same. For example, it has same mass, but it has opposite charge. It has different magnetic dipole moment also, but that is a different story. But antiparticle typically has what? Same mass, different charge. It is like electron, but it has positive charge. Okay, and one neutrino is also going to be released in this process. This is how neutrinos are born. For example, if a nucleus has too many neutrons, this neutron is going to go into proton, and this neutron, right? This neutron is going to convert it into proton, and because there is charge, negative charge, zero charge, neutron is neutral, proton is positive, so an electron is emitted. This fast moving electron emitted is called a beta minus decay, because electron has negative charge. This positron is called basically beta positive decay. This is called beta plus decay. I am not getting into detailed physics, but this is the typical you could understand. And it releases anti-neutrino. What is this? This is called anti-neutrino. Anti-neutrino is same as neutrino, right? But it has other properties, and both of them are electrically neutral. This much you guys can understand. There is one experiment going on in South Korea, and it is sometimes called double beta decay. So if someone asks you, then you guys can. There is one experiment going on in South Korea about this. The name of this experiment, you can read about it. Amor experiment, and this experiment is basically, let me tell you, this is about double beta decay. Double beta decay. This experiment is to confirm about double beta decay, right? And in this, what happens actually? Two neutrons, they are converted into, let me write, two neutrons, they are converted into two protons. Two neutrons will go into two protons, and therefore two electrons also should release with two anti-neutrino, right? And they are detecting it, and the symbol for this is written as zero neutrino and double beta decay. Okay, so you should know about this. This experiment is going on in South Korea, right? And they want to read more about neutrinos, right? Okay, so this is the idea. Quickly, let me tell you about a famous experiment, and about which UPSC has asked question. This is IceCube Neutrino Observatory. It is a neutrino observatory at Earth South Pole. Where is my pen? At South Pole. Observatory at South Pole of the Earth. South Pole of the Earth. Because we have discussed that, what we have discussed so far, it is very difficult to find neutrinos. They are undetected because they are very small light particles, electrically neutral. They are not deflected by magnetic field, so you cannot detect them. To detect neutrinos and interaction with dark matter, we have this IceCube Neutrino Observatory at South Pole of the Earth. Why? This is to detect neutrinos, right? To detect neutrinos and their interaction with dark matter. Their interaction with dark matter. Okay, dark matter. So this is again a topic for another discussion. We'll discuss about them. This is world's biggest neutrino, world's biggest neutrino observatory, neutrino telescope, telescope, and biggest observatory, neutrinos observatory. Okay, right? Sensors are distributed over a cubic kilometer of ice. They are deeply buried into ice, right? So sensors are distributed over a cubic kilometer, deeply buried in ice, deeply buried in ice. Okay. So what they are expecting actually, if neutrinos are emitted, if these neutrinos are detected, say if neutrinos will be detected, if these neutrinos are detected, right? Neutrinos they will interact with ice, they will interact with sensors, they will interact with sensors and basically ice surrounding sensor, right? Ice surrounding, right? And they will, emit some kind of radiation, and you can study those radiation. This is what they want to do, right? The properties of radiations will, make us understand about the radiation properties is going to unravel. Radiation properties are going to unlock secrets of the universe. Secrets of the universe. This is the idea, right? Okay. What are key questions? Quickly, let's discuss, and before we wind up this session, we can quickly discuss about key questions. What are key questions? What are key questions? Okay. I hope you guys are understanding it, because this is important for your UPSC preparation. They are asking questions, key questions. Key questions. Okay. So let me tell you what are key questions. Interestingly, cosmic rays and neutrinos have same origin. Let me tell you one basic idea. Cosmic rays are high energy rays, right? Cosmic rays are highly energetic rays. Let me tell you. This pen, if it is not working. Cosmic rays, they are highly energetic. They are highly energetic, highly energetic rays. And what is interesting, they are electrically charged particle. They are made up of electrically charged particle. What that mean? Charged particle. What that mean? What it simply mean? It simply means they are deflected by. They are deflected by magnetic field. They are deflected by magnetic field, right? And in the universe is full of magnetic field, strong magnetic field. So but cosmic rays and neutrinos have same origin. Neutrinos have same origin. Both have same origin. They might be emitted during Big Bang, right? Or their source is same, but you cannot trace the source of cosmic rays. Not possible. Source to trace is not, tracing is not possible. Here, let me use this pen. Okay, this is not working. I think this might work. Tracing them is not possible. Not possible. You cannot go backward. Possible, but tracing them is possible. They are not deflected, but they can be traced back. They can be traced back to origin. Okay, why? Because they are not deflected by strong magnetic field. This is interesting thing. So neutrino may be just, they can just key answers many open questions. For example, they can tell, how universe was made. They can tell you about the beginning of the universe. Okay, they can unlock many secrets, right? So this is the beauty of neutrino physics. Okay, so we are not going to get into many details, and we can keep this for another discussion. Before winding up this video, let me show you the question which UPSC has asked. This was the question UPSC has asked in 2015, and the question was about this. In the context of modern scientific research, consider the following statement about IceCube. I can, with 100% surety say, if you have not heard of IceCube experiment, you will not be able to answer this question. Only the person who has read or who has gone through, this particular term in newspaper or discussion like we are doing, only those people can solve this question. This is the beauty of these exams. A particle detector located at South Pole, which is recently in the news. It is always in the news. It is the world's largest neutrino detector, encompassing a cubic kilometer of ice. Yes, true. It is a powerful telescope to search for dark matter. Yes, it is true, because we want to understand the secrets of the nature through neutrinos, right? It is deep, it is buried deep in the ice. Yes, it is true. So answer will be 1, 2, 3. All of these are correct answers. Okay. So I hope you guys have got the basic idea about neutrinos, and we have discussed basic properties of neutrinos, including they are not massless. They have some mass, and this was in the news. Sensitive German experiment sets new limits on the maximum neutrinos mass. We don't know the mass of individual neutrinos. We know the square of the difference of their masses actually. Okay, so I hope this video is useful for you, and this was particularly for your UPSC civil services examination. If you like these videos, don't forget to hit like button, don't forget to hit share button, and if you have not yet subscribed this channel, please go through this and subscribe the channel. Thank you so very much. We'll get back with another video. Till then, goodbye. Thank you.